Let us compute the DFT of a given sequence x of n using decimation in time FFT algorithm. The sequence has the values given as 1, 1, 1, 1, minus 1, 1, 1, 1. It's a good practice to number the index of the respective inputs. Either you can write out the values separately, like x of 0 equals to 1, x of 1 is equal to 1, and so on. Or you can just put a simple index number here to indicate which value you are accessing. Next, since the value of n is equal to 8, we have to have 4 values of the twiddle factors. The first 4 values of twiddle factors are w8 to the power of 0, whose value is equal to 1, w8 to the power of 1, whose value is 0.707 minus j 0.707. This value can be computed using the exponential form of the twiddle factor e power of minus j2 pi by n. Since n value is 8 and the whole power is 1, you get this value. The next number, w8 to the power of 2, is calculated as e power of minus j2 pi by 8 into 2 because we are having square. The answer for this is equal to minus j. Next value is w8 to the power of 3, which is equal to e power of minus j2 pi by 8 to the power of 3. The answer is minus 0.707 minus j 0.707. Next, let us proceed for the structure which is called as DIT. In DIT structure, we note that the inputs are applied in the bit reverse fashion and the outputs are generated in a sequential fashion. Now, applying the inputs here as we have identified in the beginning. So x of 0 input is 1, x of 4 input is minus 1, x of 2 input is 1, x of 6 is equal to 1, x of 1 is equal to 1, x of 5 is equal to 1, x of 3 is equal to 1, and x of 7 is equal to 1. So from the given input, very carefully you have to observe and copy down the respective inputs. Now, the input for the first stage, we know that in each butterfly, the lower arm is scaled by w8 to the power of 0. The value w8 to the power of 0 we know is equal to 1, hence there is no need to perform any scaling here. Therefore, the output of the first stage is obtained by adding and subtracting the respective inputs. The top point corresponds to the addition of the inputs, the bottom value is the subtraction. Therefore, adding 1 with minus 1 gives you the answer 0, and the difference between 1 and minus 1 gives you the answer which is equal to 2. The next pair of input is 1 and 1, for which the sum is equal to 2 and difference is equal to 0. For the same value of input, again the outputs are 2 and 0 respectively, and again we get 2 and 0 as the output. Now, after calculating the output of the first stage, we need to determine the input for the second stage. We have to see wherever the values, they have to be scaled appropriately. For example, 0, no scaling, value is same, no scaling, no scaling. So all the values 0, 2, 2 are retained as it is. Now here we have to multiply by w8 to the power of 2, which is minus j, but 0 multiplied with minus j gives you the same value, which is 0. Further, no scaling here, no scaling here, and no scaling here because w8 to the power of 0 is 1. In the last one, we have to scale by minus j, but the value is already 0, hence the product is 0. Next, proceeding towards the output of the second stage, now we have to add and subtract the pair of signals. The first pair is 0 and 2, sum is equal to 2, difference is minus 2. Next pair is 2 and 0, sum is 2 and difference is also 2. For the next pair we have 2 and 2, sum is equal to 4 and the difference is equal to 0. The next pair is 0 and 0. Sum is 0, difference is also 0. Hence, the output of the second stage is also obtained. Now we have to perform the appropriate scaling to get the input for this third stage. The first 4 signals don't require any scaling. Hence, the same values are passed on. Next, we have to scale appropriately with W8 to the power of 0, W8 to the power of 1, W8 to the power of 2, and W8 to the power of 3. This gives us the result, which is 4, 0, 0, 0 respectively, because the input signals here are zeros. Next, the final stage output is calculated as sum of 2 and 4, answer is 6. The difference of 2 and 4, answer is minus 2. Next, 2 added with 0, sum is 2, the difference is also 2. Minus 2 with 0, sum is minus 2, difference is also minus 2. Next, 2 and 0, sum is 2, difference is 2. Now, after getting the output of the third stage, now we have to assign the outputs to the respective signal called as x of k. Now, since the input was not in sequential order, it was in bit reversed order, the outputs here should be sequential. Therefore, it is very easy to note that the outputs are in the order 6, 2, minus 2, plus 2, minus 2, plus 2, minus 2, plus 2 respectively. Hence, finally, we can note down the result as follows. Therefore, the result of x of k is as shown. The next example here, we are taking the input sequence x of n is equal to minus 1 to the power of n plus 1, and they insist that you have to use DIT FFT method to compute the 8-point DFT of the given input sequence. So the hint in the problem is that the length is 8. We have to do it calculation for n between 0 to 7. Therefore, substituting the value of n is equal to 0, we get the answer as minus 1. Next, n is equal to 1, you get the answer as 1. Next, you'll get as minus 1. Like that, you'll get alternating patterns of minus 1 and plus 1. Whenever the value of n is even, the sum is going to be odd. N plus 1 will be odd, and odd powers of minus 1, answer is minus 1. Similarly, when the n is odd, the sum n plus 1 becomes even, and that yields a value which is plus 1. Hence, we have alternating minus 1 and plus 1. So, in the problem, whenever an expression is given like sine, cosine, or equations like this, students, you have to evaluate the expression and compute the value for the respective points. Now, to proceed with the computation of the DIT FFT, we require the first 4 twiddle factors. We have noted down in the previous problem that the first 4 twiddle factor powers are W8 to the power of 0, W8 to the power of 1, W8 to the power of 2, and W8 to the power of 3, whose answers are correspondingly 1, 0.707 minus j 0.707 minus j, and minus 0.707 minus j 0.707. So the structure which is going to be used in this particular problem will be the same as that you had in the last one. So the method is going to be quite same here. So for your convenience, only the results of the various stages have been denoted. So what are the inputs for the first stage and what answer you expected to get as an output? The second stage, what is the input and what will be the corresponding output? Third stage, what's the input and what output you get when you apply it to the respective butterfly stages. And as we know, the output is going to be in sequence. Hence, we note down the final answer x of k as 0, 0, 0, 0, minus 8, 0, 0. This numerical is for the computation of DFT of the sequence, but the method is DIF FFT algorithm. Now, we know the difference between DIT structure and DIF structure. There are some notable changes, but otherwise the steps are the same. The given input sequence x of n is as follows. Now we are aware that we require the first 4 values of twiddle factors. So hence in the solution, first we need to note that n value here is 8 and the twiddle factor powers that we need are W8 to the power of 0, W8 to the power of 1, W8 to the power of 2 and W8 to the power of 3. And the values for these are W8 to the power of 0 is +1, next value is 0.707 minus j 0.707, the next value is minus j, and next we have minus 0.707 minus j 0.707. So after listing out the values of twiddle factor, next we move on to the structure. Now in the case of DIT, we know the inputs are bit reversed. For DIF, it should be applied in sequential fashion. So we see the inputs are x of 0, x of 1 till the last value x of 7, they are in order. So from what we have learned from the inputs, we can apply the inputs directly in the same given order. Now after applying the inputs, now we know the structure. It has a butterfly whose size is decreasing. So we go from larger to smaller, and twiddle factor multiplication comes after the butterfly. So you can imagine DIFs to be DIT, which is in reverse fashion. It's the inverse structure of DIT. Therefore, now let us compute the output of the first stage. The first pair of inputs to be considered is 1 by 2 and 0. The sum is 1 by 2. The difference is also 1 by 2. The next pair is 1 by 2 and 1 by 2. Sum is 1. Difference is 0. Again 1 by 2 and 1 by 2. 1 and 0. Again 1 by 2, 1 by 2. Sum is 1. Difference is 0. Hence we have obtained the output of the first stage. To get the input for the second stage, we have to scale the appropriate inputs. So we have seen that the twiddle factor powers are W8 to the power of 0, W8 to the power of 1, W8 to the power of 2, W8 to the power of 3 respectively. Therefore, the input to the second stage will become 1 by 2, 1 by 2, 1, 1. There is no scaling here. Now here we have to scale the inputs with respect to twiddle factors. W8 to the power of 0 is 1, so 1 by 2 into 1 is 1 by 2. Now here we have to multiply with the respective numbers, but you know the inputs are all zeros, so multiplication will also give you the value which is zeros. Next, we can compute the output of the second stage. The sum of 1 by 2 and 1 is 1.5, the difference is minus 0.5. The sum of 1 and 1 is 2, difference is equal to 0. The sum of 1 by 2 and 0 is 1 by 2, the difference is 1 by 2. The sum of 0 and 0, sum and difference both should be 0. After computation of output of second stage, we have to scale the output and give it as input to the third stage. Now we can here observe that first values have no scaling, so it is passed on as it is. So 1.5, 2, minus 1.5 because we are multiplying with 1, and next value should have been multiplied with minus j, but input being 0, we get a 0 here. Next 1 by 2, no scaling, 0 there is no scaling, 0.5 is multiplied with 1, so the answer is 0.5. Next we have 0 which is multiplied with minus j, the answer is 0. The final stage has the smallest butterfly. Again we perform addition and subtraction operation and we get the final result as 3.5 minus 0.5 minus 0.5 minus 0.5, 0.5, 0.5, 0.5 and 0.5. Now we know that when the input is applied in a sequential manner, the index of the output is in bit reverse fashion. Therefore, we have the answers corresponding to x of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of 3 and x of 7. While you are writing the answer, we have to be careful in arranging it in the correct order and listing it out. Therefore, we write the sequence x of k corresponding to the index k is equal to 0 till 7, and this is the answer obtained from this particular numeric code.
Thank you all.